everyone. So today we're going to be simplifying radical expressions. We're going to be applying our knowledge of simplifying radicals, adding them, multiplying them, all into one expression. So let's take a look. So simplify the expression below. We have radical 48 plus radical 75 minus radical 27. So the first thing that I want you to notice is that these are not like radicals. These all have different radicands. This has a 48, this has a 75, and this has a 27. So they have different numbers underneath, so we're not able to add and subtract them the way they are. So the first thing we need to do is we need to simplify these, and then from there, see if we have like radicals. So we're going to use the largest perfect square method to simplify these. And the first thing we're going to need is our list of perfect squares. Hopefully you have it with you or you write it down. It's a really easy list to make. 1, 2, 3. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, 49, 64, 81, and I'm going to stop there. So let's start with 48. The largest perfect square that can be evenly divided into 48 is 16. And remember, you can go through this list and divide, see which one is the largest one that can go into it. So 16 times 3 is 48. So this is going to separate into radical 16, radical 3. The square root of 16 is 4. So I'm going to bring down that radical 3. We get 4 radical 3. I'm going to bring down this plus sign. And then we're going to simplify radical 75. The largest perfect square that can go into 75 is 25. So we're going to get the square root of 25 times the square root of 3. 25 times 3 is 75. The square root of 25 is 5. Let me just make sure that looks like a 5. Radical 3. I'm going to bring down that subtraction symbol. And then we have radical 27. The largest perfect square that can go into 27 is 9. So this is going to split up into radical 9 times radical 3. 9 times 3 is 27. And the square root of 9 is 3. Bring down your radical 3. Now we see that these all have radical 3, radical 3, radical 3, making them like radicals. So that means we can add and subtract the coefficients going forward. Now we're going to use order of operations. We have addition and subtraction. We treat those equally, and it's whichever one comes first from left to right. So the first thing we're going to do is we are going to add these two together. Remember, we only focus on the coefficients. Do not add what's inside the radical. So 4 plus 5 is 9. And then just bring down that radical. Oops. See, I was about to do it in my head. So I just said that loud. But that's not what you do. You bring down the 3. Do not add that. Do not make it a 6. Now I'm going to just bring down this minus 3 radical 3. And we're going to do the same thing. We're going to subtract. So we have 9 minus 3. That gives us 6. And then just bring down your radical 3. Do not subtract those radical 3's. So just to summarize, we noticed that we didn't have like radicals. So we knew we had to simplify and go from there. And then once we had like radicals, we were able to perform those operations with the coefficients, not with the actual radicands and numbers inside the radical. All right, let's take a look at another example. Simplify the expression below. Express your answer in simplest radical form. And just to be clear, this is in simplest radical form. We cannot simplify this any further. We didn't round it, anything like that. So this is simplest radical form. So it's exactly like what you just did. Okay, so we have 3 radical 75 plus radical 27 over 3. These we cannot add, and hopefully they look familiar to you because we just dealt with these radicals in the example before. We're not able to add them because they don't have the same number underneath. So what I'm going to do is I'm going to simplify these separately. So I have 3 radical 75. We're going to do the same thing where we're going to simplify this radical. That breaks up into radical 25 radical 3, which gives us 5 radical 3. The square root of 25 is 5. And then don't forget that we have to multiply whatever is not in a radical. We multiply that together and we get 15 radical 3. Okay, so 3 radical 75 simplifies to 15 radical 3. Now I'm going to do the same thing over here. So I'm going to just draw an arrow, draw an arrow. We're going to simplify radical 27. Now the largest perfect square that can go into 27 is 9. So this separates into radical 9, radical 3. And that becomes 3 radical 3. Because the square root of 9 is 3. So instead of writing the original radicals that we had, I'm going to rewrite this expression, but with our simplified radicals instead. And I'm going to do that in red. So 3 radical 75 is actually 15 radical 3. So I'm going to write 15 radical 3. Bring down your plus sign. Radical 27 simplified is 3 radical 3, like what we just did. So I'm going to write that instead and go from there. And bring that divided by 3 down also. So we have 15 radical 3 plus 3 radical 3. They're like radicals because they both have that radical 3. We're going to add those and then divide. So I'm going to add those coefficients in front. We have this 15 and this 3. When we add that, we get 18. Bring down that radical 3. Bring down that division of 3. Now from here, we're going to divide coefficients. So we're only going to focus on this 18 and this 3. This 3 underneath here does not get touched. Do not divide that. Only focus on the coefficients. Now 18 divided by 3 is 6. Now we're leaving that radical 3 alone, so we're just going to bring it down. And our answer is 6 radical 3. So they were both of our answers to these questions were 6 radical 3. So let's just summarize. We did not have like radicals. So we simplified first, and then we did get like radicals. From there, we were able to add the coefficients to get 18, and then we divided those coefficients to get 6 in the end, leave that radical 3 alone.